Hey everybody, what's going on? Hope everybody had a good holiday. So yeah, we're going to talk about a lot of stuff today. So hang tight with me, guys. We got a sunspot number, the biggest amount that we've had in over 20 years. We got like a 70% chance of X flares for the next 3 days. We've also got a big long duration flares that are causing an uptick in radiation. And I'm telling you guys, it's a proton flux. It's kind of, yeah, it's kind of odd. And we'll go into what we're talking about here in just a minute. Venus is going to get hit again, guys, and probably multiple more times. We've got a couple sunspots facing over there. And will any of these things hit Earth? We're going to go over that too. I talked a little bit about it yesterday with the big eruptions. Yeah, so that's kind of what we're going to be talking about today. And yeah, so let's just kind of jump into it. So we are 5 for 5. Thank you to Tim. I see that in there. Courtney James, good to see everybody. I will say hi for 1 second here. Aloha, Kathy. I want to say thank you to the newest member of the Kool-aid Krew, Heidi Petrick. It's not Patrick, it's Petrick. Interesting last name. Surgery, thank you, brother, for always being here, even when you're at work. That's awesome stuff, man. Hey, Grace. Okay. Hey, Alyssa, good to see you guys. We will be doing a members only also, guys, and we'll go over that at the end. But I do want to just kind of jump into this, guys, so we can get the space weather stuff out to everybody that's here for just specifically to get that kind of data and not so much here to talk back and forth. But if you are wanting to be a member, guys, I guess the easiest way to show you is to show you this. I can just scroll down right here. This is in the description box underneath the video. All you have to do is click that link, okay? Or you can look at the money sign symbol on the chat, okay? And that chat will, you can click on that and you can run through it that way. Now, I know different devices are different, Apple versus Android. So you may have to do certain things with that, but I'm not quite sure. I have an Android, never had Apple, so I know Dex is really up on that too, so he knows what he's talking about with that kind of stuff. I would probably have to ask his advice on that, but okay. So guys, listen. This was a big eruption yesterday. The 9-hour, eruption. So guys, that is a significantly long duration flare. I'm calling it an eruption because it actually erupted. What in the world, Planet Hermit? Holy cow, guys. You guys see that? Oh, my. Now, I'm stopping on that one for a second. People can get mad at me all day long if they want. 50 memberships? Wow. Wow. Thank you so much. Oh, my gosh. Wow. Man. Guys, please, anybody getting those memberships, please tell him thank you. Wow, guys. That's just crazy. Thank you so much. I mean, honestly. And we're going to be doing a members only here in the next day or so. So, yeah. So cool. So cool. Wow. So cool. Yeah, and guys, we will be doing that here in the next day or so. I talked about it yesterday too. So anybody getting those, please click your notification bells on. Come have some fun with us over there. And thank you for supporting like that. I don't even know what to say. So thank you so much. Wow. Okay. So again, 9-hour long duration. So what are we doing with that? Why was it 9 hours long? And like I said, guys, an eruption's different than I guess, flare versus CME. I've always told you guys there's a difference there. That was discovered, Dr. Carrington did back during the Carrington event, okay, in 1859. That's really when space weather changed from just thinking a flare and a CME was the same thing. They didn't differentiate between X-ray and highly charged particles, plasma, erupting out. It was all one thing, they thought. But they noticed as technology got better, vision got better to what we were looking at on the sun, they could tell, right? So that, and now we have all these cool tools that we even get to look at. And this is on SDO. It's a satellite from our perspective. It's in geosynchronistic orbit, and what that means is it's just simply over the same part of our planet at all times, and it rotates or orbits the Earth at the same speed that we rotate around our axis. So it stays over white sands and down through that area, so it can relay its data back in almost real time. Okay, so it does like a figure 8 pattern. I'm not going to get too much into detail on that, but as you can tell, guys, we've been talking about this sunspot anyway. A lot of people have, and rightfully so, because look what it's doing. It is doing so many eruptions, and it's significant eruptions. So, oh, you don't know how to accept the membership? No whining. Let me look into that, and I'll see if I can't hook you up. Okay. I will look into that. And Planet Hermit, thank you again. I just don't even know what to say. Okay, so guys, you guys see that, right? I mean, that's a massive eruption. And Hilly, thank you for stopping in here. I've been worried about you, brother. I really have. I haven't seen you in a minute, and I've been asking. So, and I didn't text you because I know you got your text set up where it costs money to get messages and all that. So I didn't want to do that to you either. So, anyway. This is that first eruption yesterday, okay? And guys, that is just, and what's interesting about the second one, I want you guys to see this, okay? Well, I'm going to save the second eruption for you first for a minute, because I think it's pertinent that we look at it here on the Coronagraph first. This is from a different satellite, and what we're looking at here is a black disc, or a disc in general, that's in front of the camera, in front of the imager. So with that being said, what that means is that it's blocking the main part of the light of the sun. So we look for what we call halo eruptions. What that means is that we see energy or a disturbance around the whole sun here. Okay? What does that mean? Well, it means one of two things when you see energy poking around like that. It's either coming right at us or it's going off the backside. Now, for the bigger eruptions, we want it to go off the backside, okay? Now, for the other general ones, it's actually kind of cool to have some of this stuff hit us. We see, and it helps keep our magnetic field strong, too. It helps block things. Cosmic rays, we have to have geomagnetic activity to block cosmic rays. So, and again, guys, with that being said, we need to know, you know. Oh, thank you, Genius. Appreciate you. Wow, again, supporting. Hey, Tab, good to see you. Once again, supporting. I mean, you guys are just awesome. I just, man, I gotta quit. I gotta quit doing that. It's gonna get me a little bit emotional and stuff. Yeah. Anyway, thank you guys so much. I'll stop and give you another proper thanks later. But guys, we see this eruption around the edge here. And when that happens, that means it's either coming at us or going off the back. I've said that so many times that you guys are probably sick and tired of me hearing it from me. But it's the truth. So this is the one yesterday, okay? Now, I know everybody's focused on this one, but we've had other ones. And there was another one today that is significant also, and I'll show it to you here in just a second. But this is the one yesterday, and we may take a look at this on LASCO C3. This here is C2. It's a more zoomed in view, okay? So if I pause it right about, yeah, right about, come on, man, let's go, come on, hurry this up, right there, okay? So what am I looking for, right? Obviously, this is at least a full 180 eruption, right? I mean, that's at least half the sun. But if you go forward more, what you're seeing is you're still seeing this back here too. So there was a halo eruption, and I'm going to show it to you guys on LASCO C3 because it's zoomed out and it's actually a different color. It's blue, right? So if I go forward again here, I'm trying to get out to the furthest image I can see, and that's probably not the best thing to do there. But so if I do it right about there, what I'm looking for is just a little energy poking out on this side. If that's the case, that means either This is in a position that it's actually on this side of the sun, and it's going to, some of it's going to come at us, and we could get a glancing blow. Or it's actually on the backside, okay? Because what's difficult about this particular sunspot and the eruptions it's having, the first one that it had, it was occulted by the sun itself. Part of this was on the backside. Now, I'm not the only one saying this now, too. I figured everybody else would look at it and say pretty much say the same thing I was. And what I'm saying here is that some of that eruption was on the other side, so we didn't get the full X-ray. The sun blocked some of the X-ray itself. Now, I'm not sure exactly how much, and the reason I'm saying not sure exactly how much is because of this. Okay? We have a lot just hanging out right there. That's a continual light X-ray blast. It's not stopping. Right? So obviously this part is not on the other side of the sun. We can see it. But if you take it back to the source, you can tell that some of that is on the backside, especially back here inside the corona, right? So when we do this, I told you guys yesterday, and what I'm going to do is I'm just going to do this one frame at a time, because watch this. This is very interesting, and I think that this is why we've seen the radiation uptick here. Okay? Now remember, I talked about this yesterday, that the danger zone's over here, right? That's what they call it. I don't like calling it that, but that's what they call it. Our connection to the sun magnetically is over here. And it moves, right? It doesn't stay in the same spot. It'll move north, south, a little bit back, forth. It just moves, okay? With that being said, when we get an eruption over here and it crosses over our line that we're connected to, it'll grab the protons that are inside of that, and it'll pull it back to our planet. And that's what gives us what we call radiation storm, right? A proton flux increase. And so what you see with that is this. I can show you that here in the D region, right? That's just a region in our atmosphere. I'm not going to go into exact detail what this particular model exactly is, but typically anybody that's been here for a minute knows that this isn't usually what it looks like on a normal basis, okay? What we look for typically when I'm showing you this is the flare, okay? Because it's showing you X-ray, right? So when we don't usually see this energy here in the north and the south, north and south pole. Why are we seeing it there? Well, because those protons got sucked back to us, and they come in on the poles easiest, okay? So, and it's magnetics. It's just drawing it in. Now, listen, magnetics, electricity, and water, believe it or not, in some ways, they're very similar. Most of them are looking for the easiest path, right? We know that water takes the path of least resistance. Okay, electricity does something very similar. Magnetics, it's going to follow the opposite pole, and that's what it's doing, right? In other words, that's its easiest path. It's trying to find a stable position. Everything is, right? That's even what causes aurora. The charged particles trying to go back to their original state, and they give off that light. But I'm not going to get into detail on that. But we don't typically see this stuff hanging around. These are the protons that got sucked back in here. Now, the bullseye signature here is the flares themselves. So each time you see that, and it gets into at least that color, like an R1, it's an R1 radio blackout. Okay? Now, these things are very short-lived. The radio blackouts typically are. Now, depending on how strong and how long the duration is, right? So I can safely tell you that we had a 9-hour radio blackout yesterday. The whole time that this thing was producing X-rays, we had radio blackouts. So I don't know how else to say it. That's all I can say. Plus, guys, these things are being data collected here, right? So when we're going over this, we have to understand that we got certain ways to tell a little between each sunspot, what kind of X-rays are coming from it, right? But when you have these sunspots like this, and they're all flaring at the same time, it's hard to tell exactly how much of each X-ray is coming from what spot. Okay, because we're looking at an overall X-ray data. Okay, so in other words, the X-ray up here is a collection of all of the X-ray being produced on the sun facing Earth. It's not like singling this out. So when you see this, yes, believe it or not, it's the X-rays are being calculated from all of these. But we know when we see X-flare type of situations, we see this, right? These kinds of signatures. So we know that that's where most of it's coming from. I just want everybody to understand that we can have multiple flares, and that's exactly what happened back in May when we had the big G5 storm. We had 2 sunspots flaring and erupting at the same time that were facing Earth. So that's what we seen. And that's what caused everything, and just the back-to-back train of CMEs that hit us, right? So, yeah. But this thing was significant, okay? But check this out. I have to show you guys this. This was so cool. Anybody that watches weather here on our planet, right? You guys have seen, obviously, tornadoes. There's a guy, his name's Reed Timmer. Most of you guys probably know who he is. He is the GOAT of tornado chasing, right? Storm chasing. And he captured a tornado, oh gosh, I don't know, a couple months ago. He intercepted one of them in his Dominator, that vehicle that they actually have buttons on the inside the car, and they hit the buttons and it puts spikes into the ground so they can actually drive into a tornado. So if anybody's seen that movie Twister and Twister 2, the Twister 2 did something similar with it. It had augers that actually drilled down from a truck. But anyway, I'm saying all that because he's seen a multi-vortex tornado. But this thing started out as a horizontal signature, or a horizontal funnel, okay? Now that only happens in the strongest storms here on our planet, okay? Now I know that the physics are different out here, obviously. What we're seeing here is not wind, okay? Solar wind is not actually wind that like we think. Solar wind is charged particles moving, okay? That's all that is. Coming at us, right? That's what we call solar wind. And the more of it we get, obviously the storm levels go up. But watch this. Watch right here. We see like a horizontal. The horizontal vortexes, like I said, here on our planet, are the most strong, typically, overall storm. But as I'm showing you this, I want to show you this at the beginning. Watch this first eruption flick out. Okay? See how fast that did that? Now, what did you guys see right there? Number one. This thing is like spinning. Okay? It got shot off the sun so fast, it's spinning like that. Now, I mentioned this yesterday, and I hadn't seen this part yet, and I hadn't really analyzed it all that much. Remember I said that this is the danger zone over here, right? So I'm sitting here and I'm questioning, how the heck do we get a eruption on this side that's actually going to be able to cross our line on the other side of the sun and send us protons, right? I was trying to figure that out. And this is why. Check this out. You see the direction that thing is moving now? It started here and it actually went this way. So this, like I said yesterday, I said this was a possibility. That a lot of this was south and on the other side of the sun. And that's exactly what happened. It flicked out and it went this way. So it was wide enough on the backside. Okay? This eruption, a lot of the width of it, for whatever reason, ended up being on the backside and here, on this side. That was the first eruption. Now I'm going to take you guys over here and show you LASCO C3 because we see it better over here. Hopefully it'll show it. Nope. This is too far ahead, too far advanced. Oh, Dr. Tony Phillips has got it. Here. Dr. Tony Phillips is, guys, go over and check out spaceweather.com. Please. Go show him some love. But check out this. That's the eruption yesterday, but I want you guys to notice, watch as this thing runs right here. You see that? Right there. I'll do it again. Okay? That is a halo eruption, but the halo part is actually on the other side. So I don't think that part is coming at us. But this is why we seen a radiation storm. It was wide enough down here on the south that wherever our magnetic connection line was on this side connected, it crossed over. So it grabbed those protons. So just understand that that's a very powerful blast. It's very directional. And it's, you know, when we get these big blasts like this, it becomes really, really complicated, really, really quick sometimes. And that's exactly what's happening right now. So we got this first blast right here. Now, let me take you back here to SDO, or Soho, and I'll show you the next one, because we had another one today. Actually, we had a couple, but this is the one I want to show you. Okay, so it's coming from that same spot. The same sunspot. And I told you guys this yesterday that we need to be paying attention to this thing, because this thing's not done. It's not done by no stretch of the imagination. There's the second eruption, and then here's the third. Okay? So we're still looking for halo signatures, and we're not getting it this time on this one. Alright? At least not yet. Not that I've seen. So, let's go back here to SDO again. And I want to show you the second eruption here, or the third one. The second one was an eruption. Okay? So, there's the first one. It hangs on like that, which is so cool anyway. And guys, you can see how some of it's on the backside. I mean, you can see it right there. So I know people have been questioning that, but it's obviously that's on there, on the backside, some of it. Now there was a second eruption. What time was that one? I think it was right around 4 or 5 UTC or something like that. Let's check. Oh man, hold on a minute. Are we still good, guys? Give me a 5 for 5 in there if you could. I hit a button on my keyboard, and I used to use it as a hotkey, so I want to make sure that I'm not like stop the stream or something. Let me I don't know if I have or not. Somebody give me a 5 for 5. I'm gonna keep moving, but anyway, I'll look down there and see if you guys give me a 5 for 5 here in a second. Okay. So here is the other eruption. That was the second one. That might have been the third. Yeah, it was the third one there. Okay, we're 5 for 5. Good. Thank you, guys. Appreciate you. All right. Now, I'm going back, because there's the second one right there. See it? Now, keep in mind, guys, that these other ones are helping with that. Okay? So, we had multiple R1 radio blackouts, and this one here actually had a CME involved. So this may be the second CME that we're seeing on the Coronagraph here. Okay? Not quite sure. It looks like it because it's in that position. See that? So that could be it. But I'm not, you know, I guess it really doesn't matter at this point because it's actually going away from us. But see how it has CME right there? You can see the flare happen, and then you see a little bit of a disturbance here in the corona. Now, guys, I want to also tell you this too. A coronal mass ejection is just that. It's a coronal, which is the atmosphere of the sun. You got mass in there, charged particles. Ejection. It's ejecting, right? But it doesn't have to eject out of the corona. Okay? So the technical name, and really the name that we all should be using, is ICME when it leaves the sun. If it's able to get away from the sun, and the sun doesn't recapture it, because it's powerful enough, and magnetics and gravity and all that stuff. It's called an interplanetary coronal mass ejection, which means nothing more than it's actually going out into our solar system. That's what that means. Okay? So, anyway, let me do this. Now, check this out, guys. Okay? So, what I seen when I seen this one, watch in here. Okay, there's that second blast, or the third one, but it's the second big one. Watch what happens after, right here. See that right there? That was so cool to me. I mean, so cool. Look at that. That's so far away from the surface, number one. It starts spinning right there. And it just hangs out, and then it ejects out. It was so cool, man. I don't know that I've seen very many do that. And that's what I'm trying to say. You see that? Look at that thing. It really is spinning like that. Look at that. Now, it's because of our perspective. That's what I want to point out. If we were looking at this thing from over here, it would not look like that. You wouldn't see that spinning signature. Okay? You would see more of something just straight on. So yeah, these things here, most of these are going to smack Venus right in the face. Just saying. That planet has got some issues coming. Not even playing. But you guys look at these, okay? So, there's those eruptions. Now, what I want to do now is show you this, okay? This is Earth scale right here. This is a HelioViewer. And what this is it's the same satellite as this. It's just got a different imager or a different filter on it, okay? And I show you guys this a lot because these are sunspots. Now, I'm talking about sunspots because of this. Right here. We have to go back to 2001 to see that many sunspots in a month. So, just understand that. And I talked about this at nauseum yesterday, but I wanted to point it out specifically today. I wanted people to see this because this is significant. This is very significant. This is more than double what they forecasted for this month. So we have to understand that we're still learning. And I want people to really grab a hold of that. It isn't because it was wrong. It's because we got to learn from this. So I'm not pointing it out to say, oh, somebody did this wrong. No, that's not what I'm doing it for. I want you guys to understand we're all still learning. There's so much that we don't know. And that's why it's important for us to question each other, question the science we think we know, and question whether, and be able to land wherever the truth is. And that sometimes is going to be towards what we are taking as accepted science right now. And sometimes it's going to mean that we have to, hey, we need to change this, right? We can't be biased one way or the other. And I see that so much on both sides. And it gets very irritating because could you imagine if the smart people in this world would drop those biases, come together, and figure things out like that? And we know that that's pretty much an impossibility because there's so many, I'm not going to get into all that. But what I'm saying is, that's why I nowcast, I give you guys the information. I want you guys to see this. I want you guys to be able to draw your own conclusions. Because not just for you, but for me also. I learned from you guys so much more than what I could ever say. And I have to, I continually say that because it's simply the truth. So they were forecasting 107. We got 215. So yeah, I mean, and this sun cycle, and I showed you guys this yesterday, is very reminiscent of solar cycle 23. So if that was to hold true right now, this is the kind of sun cycle we're going to be seeing. Now, again, we get a double uptick, a double climax, or a double peak, right? Each sun cycle, we see it. You see it here too, even on the smaller ones, here and here. Okay, so we see that. It's very easy to see in the data when you go back and look. Heck, you can even just do it right here and look. You see the double peaks on almost everything here? So that's what happens. So it's much like a farmer's almanac where they take historic data and that's how they pretty much are forecasting things. So, but I did want to point this out because we leveled off with our protons, but then guess what? You know what changed? Okay? This third eruption right here is what changed. So we got another large eruption right here. Now this one here actually does, in my opinion, have a chance of giving us a glancing blow. Or even a side hit. I'm waiting on models to update. They're not updating the models very quick right now because they're wanting to get it right. And I don't blame them. I'm serious. We need to make sure that we get it right before we put the model out because people are going to start thinking it's this, that, or the third. You don't want to come out and say, oh, this thing's missing, and then it hit. Or vice versa. You don't want to come out and say, oh, this is going to hit, and then the next time something happens, nobody listens. Okay, so there's drawbacks to both of that. And that's why it's so important to understand that we can't just be drawing conclusions at the drop of a dime. Can't be doing that. And that's why I tell everybody, hey, it's going to take 2 to 3 days typically for a CME to hit. Okay? We got time to talk about it. Now, if it's a grid down type of situation, guys, most likely I'm not going to be able to even get out here and tell you. Because the fact of the matter is, we don't get real-time data, number one. Number two, even if we did, it's probably going to hit some of it, the flare part of it's probably going to hit so hard that, yeah, the communications are going to be affected, and yeah, just saying. Now, typically on like a grid down situation, we're looking at a CME getting here in probably like 12 to 15 hours. And, if not if not multiple ones like that. So, yeah, I can't remember exactly how long it took for the Carrington event to hit. It was less than a day, if I remember right. So, but typically, on a regular CME type of situation, we definitely we got time to talk and look, make sure that what we're saying is correct, okay? So, yeah. So, as far as the radiation storm, I do want to let you guys know that, listen, look, they're saying a 25% chance for the next 3 days that we get into storm level. Now, S1 storm means absolutely nothing to me and you. Okay, I'm not even kidding when I say that, and I still question why they even did it like that. But I guess for scientific purposes, they needed to do it like that. As I kind of dove into it and tried to figure out why. Let me find the space weather scales here. Okay, so this is a Space Weather Prediction Center, NOAA, right? If you guys go down to any NOAA page over here, you can scroll down to the bottom. You can get to everything that I'm showing you right now. Okay, so what I'm showing you right here are storm levels and what we can expect during each storm level, right? So we have geomagnetic storms, solar radiation storms, and radio blackouts. Radio blackouts are flares. Radiation storms is an increase in proton flux. Okay. Geomagnetic storms, charged particles smacking our magnetic field. Okay. That's what those are. So that's what geomagnetic storms are. It's a CME hitting, pretty much. Okay. Or a coronal hole stream. Charged particles. I'll just leave it at that. But you can come over here and read these, guys, okay, if you really want to know exactly what we can expect. But you're going to find that we're probably seeing a little bit more than what is forecasted here, even on their scale, okay? I don't say forecasted, what we can expect. I do think they need to uptick this a little bit. Not a whole bunch, just a little at this point, okay? I don't know if, what it would take to get something like that done. It would not be an easy task, I'll tell you that. But for what we have right here, it is pretty close in the stuff that we see. Okay, what they're telling us here is almost exactly what we see every time we get these levels of storms. So, like I said, radiation storm, S1, the first level, right here. Okay. Look, biological effects. None. Satellite operations, none. Other systems, minor impacts on high-frequency radio in the polar regions. Okay, so if you live on the North or South Pole and you're using high-frequency radio, you might have an issue. And I could probably show you 10 or 20 people that have that effect on the whole planet of our 9 billion. So, I'm just wondering, and that's an exaggeration, obviously, but it is what it is. Thanks, Christopher. I appreciate that. As a matter of fact, I'm going to highlight that comment. Thank you for putting that in there. I knew that's what it was. Hey, Aliyah, good to see you, girl. Thank you, Christopher. I do appreciate that. He's letting you guys know about how fast the Carrington got here. The electrons got here a little quicker than the rest of it did. But, again, That's all a bunch of another conversation we can have. Hey, J. Poss, good to see you, bud. Kathy, aloha, Stephen A. Hey, you're good, Stephen. You always come back and watch. You always tell me. Yeah, see mine frequently. Yeah, they do, Z-Cal, for sure. Hey, guys, give me a roll call in there if you could. And please read that comment that Christopher left there. He's right on. I mean, honestly, he is. That's 100% correct. So, anyway, guys, that's what the lowest level of radiation storm is. Basically, we don't have to really worry about it, okay? Most of us. But then you start getting into moderate S2, passenger and crew and high-flying aircraft, okay? Same thing, up towards the poles. And then stuff just goes up and up and up, guys. I mean, I've never seen anything get up here in the S4, S5 range. I'm not sure exactly what it would take to do that, to be honest with you. I don't know when the last time we had one that big. Or, you know, I really don't. I need to go look at that just so I know for myself. But geomagnetic storms is kind of where we usually land at when we start talking about effects on us after a flare. Okay? The flare is here. Flare gets here, we get its effect in 8 minutes. Okay? It's moving at the speed of light. It's X-ray. Okay? So, and these two used to be thought of as the same. Like I said, during the Carrington event, the flare and the CME, they thought it was just one eruption. It's not. It's two different things, and I've explained that a lot. So we're looking at X-ray for radio blackout type of radiation, or radio blackout storms. That's what causes it. Now, guys, they can cause other things too, not just radio issues. But you guys can read that if you want. And again, guys, these links are in my description box too. But you can just go to NOAA, Space Weather Prediction Center, scroll down the bottom, and I'm telling you, you're going to get everything that, well, not everything, almost everything I show you. But geomagnetic storming, that's where we start talking about like real effects that we really want to pay attention to. Flares and geomagnetic storms. So, yeah, you guys can read all this if you want to. But even a G1 storm can have weak power grid fluctuations where it could like falsely trip out stuff and things like that. So again, also, guys, this affects our health. And I'm not just saying that. This is not some whatever backwoods whatever. And if it was, if it's true, who cares, right? This affects our health. And there's so much science behind it now. There's no denying it. We got cardiac surgeons and whole departments that actually look at space weather before they do surgeries. It's crazy. You know, I don't want to say it's crazy. It's amazing. There's a better word for that. That's how much we've learned. And it's continually going that way. And it's awesome that they actually consider that now. You know, I remember being a kid and seeing space weather getting broadcasted on the nightly news about once a week, right? When's the last time you guys seen the space weather broadcast on regular TV or any kind of TV? You haven't, and that's too bad, you know. Like Dr. Timothy Scope, she's been on the Weather Channel. You guys can go look at that on YouTube. She's a rock star in that world, guys. I'm telling you. And for her to, you know, she does that Millersville University. It's awesome. And she shares all that information with us for free on YouTube. It's free college, and she describes it in a way that you can understand it. It's not a bunch of word salad. And if there is a word that she has to use that's really big, she takes the time to explain it. It's an amazing place to go over there, guys. So please go check her channel out. I don't just say that just because. I've watched her for years, and she has always pointed me in the right direction, even when she didn't know she was. Okay? So, please, go over there and check out her channel, Dr. Tam with the Scope. Hey, Kay, thank you for the gifted memberships. Appreciate you. Wow. Wow, you guys are just awesome. So cool. So cool. Hey, Christopher, you got a membership, bud. There you go. Thanks, Kay. Appreciate you. All right, wife. Wifey's calling, huh? All right. Hey, JoJo. Hey, I love that avatar. All right, let's go back and say hi to the. I know you guys gave me a roll call in there. Let's see if I can't get back here. Let's see where you guys are from. Buckeye Jim, heck yeah. Ohio, Colorado, Robert. Karen's from Northwest Ohio. Heidi, Bothell, Washington. Awesome. And thank you for becoming a member today. I really do appreciate that, guys. I don't want it to seem like I don't say thanks to you guys enough either. That are just getting memberships on their own. Okay, so please don't feel that way. So I think everybody is just as important as anybody else. And when you come out of your own pocket to try to just, support what we're doing here, I take it very seriously, and I really do appreciate it. My wife always tells me, tell them thanks for me, would you please? This is all hers. I wouldn't have any of this stuff to even come to you guys. She got it all for me. So this is all hers. But anyway, thank you again, guys. And thank you, Planet Hermit, for that huge gifted membership. 50 of them. You did that once before, and I thought, man, that was the biggest one I'd ever seen. And you just did it again. Wow. That's all I can say. And Kay, thank you so much. And who else gifted earlier? Oh, Genius by Birth, you gifted some too. I'm telling you guys, she supports the whole community. I see her gifting memberships over on Marfugal, everywhere, guys. I mean, we got awesome people. I'm telling you. So yeah. Wayne's Yell, what's that? Hey, Jen from Illinois, good to see you. Hey, is Ripper here? Hey, Pan B. There you go. What's up, Ripper? Good to see you, bud. Hey, I sent you a text. You might check that one out. It's not a big deal. I just something I noticed. That's all. I'm horrible at that, by the way. My spelling sucks. Let's do what we can to get way. Yes, please, guys. Buckeye Jim, I would love. That's been my goal since I started. Since I started doing consistent videos, I really would love to get to 100K. So I never thought I would have as many supporters as what I got now, guys. And let me tell you something. Without people like Rip, and without people like Adam and Dex, and Trinity, and Ilea, and everybody else that's here, okay? But everybody that was able to influence or help me in a way to get the word out has. And it's just amazing. I'm so grateful for it. They're good friends of mine. I call them brothers and sisters. I really, truly do. And that's how I feel. I haven't even put a hug on these people. And I care about them more than a lot of people in my own real life. It's crazy how that works nowadays, but it's just the truth. Ripper's my brother right there. Hilly is my, oh my gosh, I've known Hilly probably longer than anybody I've known here. So, yeah. Well, thank you, Stephen. Hey, Pan B. Yes, Pan B's just the next town over. Well, thank you, Ilea. That's awesome. Thank you for that comment. Guys, let me tell you something. When I get a comment like that, it takes all those negative, just nasty comments I get up to, including threatening my life and my family. One comment like that can wash away about 50 of those negative ones. I'm telling you. So, yeah. Okay. So, let's go ahead and get back to this. Now, guys, I think we're getting some sort of hit right now. And this has kind of got me a little bit on the back here, back on my heels, because I'm not sure why. So, as you can see, this is velocity, speed. So what we're seeing here, guys, is the sun's off to the left. It's right, and energy's moving left to right, right? So with that being said, oh, before I forget, before I keep moving, please go support Axe and Nacho, please. They do an awesome live stream twice a week up there. Put out a bunch of shorts. It's awesome. Go check out Mark Pyers. Everybody, guys, anybody in my subscription list, go look at my awesome channel list. Start from the beginning and go over. There's links for everything. Lifeboat, all of it. It's all there. I mean, you guys know I support everybody. So go over there. Go check them out. All right. Now, guys, look at this. This is just so awesome. when you see this happening, and you see our magnetic field just kind of just push things away. So you got the sun sending stuff at us, and our magnetic field's doing its job. Okay? Just because this looks like it's an uptick doesn't mean it's bad. Especially when you see it symmetrically hit and then go around both sides the same. That right there was a definite hit. Okay? This right here. When you see that, that is a definite, hey, we're here kind of thing. When did that happen? Oh, that just happened. What time is it? That just happened not too long, an hour ago. Not even. Let's, well, this is density down here, okay? And this is magnetic pressure. Now, I'll be interested to see what the pressure does here. Oh, wow. Okay. I wasn't expecting that, okay, just to be honest with you. Look how quick that went. But check that out. Look how quick it went away. Look at that. I don't know if I've ever seen the magnetic pressure come that quick and then leave just as quick. Let me check something. Okay. I was looking for the data dropout. We're getting this data dropout once every 24 hours right now. Okay? Or roughly 24 hours. So, yeah. If that was happening when we seen, because we get the data's collected on a lot of these satellites, guys. So when the satellite's in the wrong position, or in the position where it can't really relay the data or collect it, we get a little bit of missing data. But that's what's happening there. So I don't think that that's what's going on here, though. Let's go back here. So, but you know, as fast as it hit, it went away. That is kind of odd. I mean, that was, what time exactly was that? So right there, what time is it? Yeah, I mean, that's like an hour ago. Okay, so what we're going to do, first off, I'll show you the density real quick. It'll probably take all this white, and I haven't seen it yet. This whole thing is going to turn almost completely blue, and then it'll go right back to white. Watch. Exactly what happened. So yeah, so there's the hit. That's density, so that's hitting right there, and we know that that's a hit. Now our magnetic field looks like it did its job, right? Because you could tell how it never really got, you know, too far in. And then bam, there's your bow shock. That's the first point of contact of space weather to our magnetic field. So as we go forward here, and then it does look like we might be starting to get another hit. Now, I want to show you this too, okay? We got a Y and a Z cut, right? We got horizontal, and then we got vertical, basically. Different axes. You can kind of tell where we're at as far as, are we negative BZ or positive? You see this negative 10 here? Positive 10? That's the Z in the BZ that I talk about all the time. Okay? We need a negative 6 or bigger for it to really, or more negative, for it to really let the energy in. So I say that for this reason. Now, let's see here. I want to show you the discovered data. I thought I had it up here. I might not. I guess, is that it right there? Here it is. Okay. Now, so this is our BZ, this red line. When it gets to negative 6, it highlights it in like a lavender purple. We've been in the positive a lot today. Okay? Right here. Well, the end of the day. We're still in the positive. But do you see what's happening here? It's starting to separate from the BT a little bit. I'm not going to get into what that is. But you can see how everything started moving right here. Okay, you got the phi angle, which is the solar wind, the polarity inside the solar wind itself. And then you have speed and density. Everything moved at the same time. So that was a hit of some sort, but it looks like we just kind of deflected it off pretty well because of this. We weren't even at 0. We were at 6 or 7 positive. So it has a, you know, just like -6 will draw it in, +6 is going to push it away. So remember that. So yeah, that's what's happening there. All right. Now, I will say this, you know, okay, so I was showing you this here because you can actually see the tilt on this model, the -6 that I'm talking about. So when we're looking at that, and if I, again, back here, what time was that? 1800? I'm not sure if we can go all the way back to 1800 here or not. We'll try. See if we got enough time here. Let's see. See if it lets us go back that far. Nope. But anyway, what we're seeing here, guys, you can see on a normal, like, just ambient conditions. You see this? We get this out here in the front, that signature here. And we get our magneto tail, all the stuff in the back, right? I've been talking about that a lot because of Aurora, the reconnection event we have. That from behind here, when we got broken field lines here, and they reconnect back here, sometimes they'll send an Aurora substorm. Basically, it's a big rush of energy because they reconnected. It's like shorting stuff out. It's going back to ground, that kind of thing. So that's our tail, right? You can literally see when this thing goes negative in a big way, this will actually be tilted down this direction. This tail here will be up here. So you can actually physically see it on this model. So just know that. Now, I'm not going to bore you with this either. I'm trying to kind of get through that. But I can tell you this too. Look at this. Now, when we see us get hit, and it stays almost vertical like this, right? Or horizontal, depending from your viewpoint here. Flat is what I'm saying. So we got something coming in. It hits our magnetic field. It's strong enough, and we're strong enough at the time that it's pushing back in such a way it makes everything kind of flat. And then as it rushes over, you see what happens? Okay? Now, you're also seeing the compression and rapid expansion at the same time. Okay? So we get hit, and there's your compression. Now watch us rapidly expand. See? Happens that quick, guys. Now, we also have an Australian model doing the same thing, just in a different visual. Very simple, and I love it. Bow shock, this is our satellite line. Let me hit play. And you've seen that thing flick right there. So I'm going to hit it again. Actually, I can take this thing back to the same... What time was that? Right about 1 o'clock, right? Right there? Okay. So let's match up the times. So let me go back a little bit further here. So you can see the thing moving back and forth, right? Look, there it is. Okay? So you see that, right? I mean, I know you can see it. Yeah. So you see, let's, all right. So we'll go forward. Now watch. There was your, part of your compression, but watch this. Here it goes. Right there. Okay? So you see how we had compression and a rapid expansion again. So if I just click that again, we'll watch it. See, you can see it going like a tuning fork, right? I mean, it's just kind of crazy. But yeah. Hilly, I love you, brother. I really do. No kidding. You guys are awesome. Every one of you guys are awesome in there. Can you play them slow motion? Yeah, kinda. Are you asking me? Nurka? Let's, I can, a little, I guess. I can slow it down, I think. I'm not sure if I've ever tried to slow down this particular model. No, I can't. You can't really slow this down. You just got to watch it. I could record it and then slow it down that way, but yeah, what we're seeing here isn't that big of a deal. But anyway, so yeah, guys, I mean, that's what we got going on. There's not a whole lot more to say other than, hey, we need to be making sure that we're paying attention. Now, Dr. Tony Phillips says no CMEs are heading to Earth right now. I'm not sure he's seen. Well, it says for the next 2 to 3 days. He hasn't shown us the third eruption yet. The one that had the horizontal signature here. Now, I guess I could show you guys a different angstrom here on this. I'll tell you what. Let's check out the 304. This is ionized helium. Remember, it's just a filter. And it's extreme ultraviolet, and they filter out all the light except for the one angstrom they want us to look at. And that angstrom shows up specific gases. This one's ionized helium, the 304 angstrom. That's all we're seeing in this one here in just a second. Right here. Okay? So it gives us different visuals, and it helps us understand things better. Look at that. That is so beautiful. It really, truly is. I mean, it's one of those things that I can just sit here and just be amazed by for a week. I'm not kidding. It's that cool to me. But you see these other eruptions, right? It's not just here. So things are, there's something else too I wanted to point out. Let me back this off. This is something I've been noticing the past few weeks. Almost all of our sunspots are in the south right now. Hey, Alan G, good to see you. So I don't know why. I don't. I have no clue why that is. Now, there's probably some scientific reasoning for that. Okay? At this time, I know in September, historically, we see an uptick, guys. Some of the biggest storms in September, October, right? Thanks, everyone. Have a blessed night. Thank you, Carla. That's so cool. Thank you for the super chat. Appreciate you. So cool. Thank you. But they're all showing up in the southern hemisphere right now, and I'm not really quite sure why. But I think it's also important to show you guys this. This is the Earth scale. So I've shown you guys sunspots in the past that have been probably 5, 6, 7 Earths wide, right? The bigger ones that I've shown you. Guys, this sunspot is not that. Okay? I'm pointing that out for a reason. It doesn't have to be big in size for it to be big in power. And what makes it big in power is how much energy and how unstable it is. You see these smaller cores? We have negative and positive swirling around each other right there. So when we get that reconnection, that's what causes a flare. And it's also why we can see, and I'm going to pause it here. I'm going to take you guys back to right there. You can see the individual loops here. Okay? And to me, it's, number one, it's amazing. I mean, it just looks really, really cool. But you can definitely see this. Okay? Now, I know it's zoomed in quite a bit here. And I'm going to just run it like that. Okay? So you can see the individual loops. That's that 9-hour flare. Look at that. It's so cool to me. I can't get over it. I really can't. But before that, did you see what was happening? It was communicating over here. So it's communicating something back here on the backside of the sun. My guess is there was probably another sunspot over here. I could be wrong. Okay? But, I like to think I'm not on this one. But you can see how it was still communicating, and then it blasts off like this. So a lot of times that's what we see. Two or three sunspots connected to one another. They're communicable. Okay? In other words, they're sharing things back and forth, right? But you can see these darker ropes too. Those are magnetic filaments. When those erupt off, that's a CME. And, I've talked ad nauseum on what those are. But look at that one. See? I mean, I think that was that third eruption. Okay? Now that one there opened up a little bit of a canyon of fire. Just a little one. And we see that often when we get blast from the sun. It looks like it peels back, and it's really not fire in the aspect that you might think. Okay, it's just there's a whole lot of different things I could show you and share with you on that, but it just takes too long. I can't can't do it every stream. You know what I mean? But yeah, so all right, guys, I am going to go ahead and end this one. Guys, thank you so much for the gift of memberships, the super chats. Planet Hermit, wow, 50 of them. I just dropped my jaw right off. I'm still picking my jaw up off the floor on that one. It's so appreciated. Just know that my family really appreciates it. I appreciate it, all of it. Hey, Carla. Okay. Carla, you're killing me with that one. Oh, goodness. You're killing me with that one. Everybody's going to love that one. Look at that. Look at all the hundreds just flying in there. Look at that. That's awesome. Killing me. Guys, if anybody that's a member, please come to the next members only. The last members only we did last week was so much fun. And I found what we do whatever we want, really, pretty much. And also, guys, I do want to point out the last week, I asked you guys to give me try to guess my favorite color and my favorite movie. And I told you it was from a series, but you have to guess the specific movie. Now, listen, I'm going to go look today and see who won that, okay? So whoever guessed, the first one to guess it in the comments over there, I'm giving you guys, I'm going to send you guys a deck of cards, and they're called Sunspots, and it's a bicycle deck, okay? It's bicycle, really good quality cards, and I think I sent some to Ilea. She's in here. She'd probably tell you how cool they are. They don't make them anymore. My wife is so awesome, she found a couple bricks of them, and I'm giving them away to you guys, here and there. So what I'm going to do, I'm going to go back and look today, but I'm also going to do that for this live stream. Okay? So I'm trying to think of a question or what I want you guys to kind of answer for me. And I got to make it specific to me because I can't have you guys just Google stuff and all that stuff. Let's see here. What can I say? And I sent the answer to, I think I sent it to Ilea and a couple other of my mods so they knew that that's what it was before people started guessing. So somebody couldn't say, well, you just picked this person. No, we're not doing that. We don't do that anyway. But let's see here. What can I say? All right. I got one for you. What year did I hit puberty? No, I'm just kidding. Sorry. That's my dadness coming out there a little bit. Let's go with what year did I last live in Ohio? I don't live in Ohio no more. Okay? If you guys can guess the year, you guys will win a deck of cards. Alright? And I'll send them to you. But you guys got to be willing to email me your address or P.O. box or something. So don't go in there and win and then just not give me an address. You have to email that to me. I'm not going to have you do it like publicly or nothing. But anyway, 2026. Hilly, I love you, brother. For real. Hey, Tin Top. Hey, Pam B. Heck yeah. I know. Yeah. Heck yeah. Yes, I used to be a Buckeye. What do they call us? Worthless nuts? Ain't that what they call them? Anyway. Yeah, because you can't really eat them, I don't think. Unless they're peanut butter and chocolate. Those are really good. But, alright, guys. I am going to pop off, guys. For real. So, guys, get over and check out Adam today. Adam and Dex. Marfugal. Whenever they go live. Let's see here. See ya, Leah. Thanks for being here. Hey, J-Poss. Alright, guys. I am going to go ahead and pop off. Come back to this video. Leave your answer in the comment section. Tell me how much you love me. No, I'm just kidding. And we'll keep moving with that, alright? But yeah, if you want a chance to win those cards, please do that. I mean, honestly, they're really cool too. I used to do some sleight of hand magic, so I got really good at knowing what cards are good and all that. So, hey, Stephanie, good to see you. Cindy Lou's in the house. Aloha, Kathy. I hate leaving you guys so quick, but well, it's been an hour. But anyway, all right, guys. God bless. Yahusha saves, and as always, you can. Water boy. Yeah, you can drink this Kool-Aid.